Alright, I'm going to run you through the steps on how to calculate total resistance, total voltage, total current, and the current through each component in a parallel circuit. One thing that I want you to understand, the difference between a parallel circuit and a series circuit. If we look at our schematic here of the parallel circuit, our electricity has more than one path to flow. And so, for instance, if this was some type of LED or light, if I removed this one, the electricity could still reach the other two bulbs, and so these two would light up. The difference between that and a series circuit, if I were to remove, if these were LEDs and I were to remove this LED, the current couldn't, or the electricity could not continue to flow, and none of the lights would light up. So that's the difference between a parallel and a series circuit. So again, the first thing we're going to calculate here is total resistance. Total resistance in a parallel circuit is different than it was in a series circuit. And so the formula for total resistance in a parallel circuit is the reciprocal of each component, its resistance. And so if we look at our formula here, we can plug that in to our numbers and go ahead and calculate it. So total resistance is equal to 1 over the resistance of component 1 plus 1 over the resistance of component 2 plus 1 over the resistance of component 3. Plug in our components. The first one we have is component 1, 470 ohms. We add that to component 2, which is 2.2 k ohms. And so again, if we convert that to add these together, they have to be like terms. So I will move the decimal 3 places to the right, and that becomes 2200 ohms plus 3.3 k ohms. Again, move the decimal 3 places to the right to convert it to ohms, and we have 3,300 ohms. So we plug this all into our calculator, figure the bottom, 1 divided by whatever that total would be, and we get 347 ohms of resistance. The next thing we're going to calculate is total voltage. This is one of the things that you need to just understand about the difference between a parallel and a series circuit. Total voltage in a parallel circuit is just equal to the voltage at component 1, which is equal to the voltage at component 2, which is equal to the voltage at component 3. And so what we're saying is that since the electricity has multiple paths, there's no voltage drop in a parallel circuit, which is different than a series circuit. Where the difference comes in is that the series circuit has voltage drops and a constant current. And a parallel circuit has constant voltage and it has current. The current at each component is variable. And so those two items are switched in a parallel circuit. And so now we're going to calculate the current at each component. So go ahead and write that. And we'll use Ohm's law to do this. And so the current at each component, here is component 1, here's the current at resistor 1, and so that's what we're going to calculate first. The current at resistor 1 is equal to the voltage at resistor 1 divided by the resistance of 1. And so the voltage, if we look at our item, is going to be a constant number in a parallel circuit, so it's 15 volts. The resistance at 1 was 470 ohms. 15 divided by 470, and we get 0.03. And so we need to convert this, so I'll move the decimal 1, 2, 3 places to the right, and I get 31.9. Current is measured in amps, so it's 31.9 milliamps. Alright, we'll go ahead and continue our current calculations up here. And so the current at resistor 2 is equal to the voltage at resistor 2 divided by the resistance of 2. Plug in our numbers. 15 was our voltage. The resistance at 2 was 2.2 k ohms. 15 divided by 2.2, and we get 6.8, and because we're in kilo ohms, it's already in our standard unit of milliamps. And so we'll just say this is 6.8 milliamp. Last one, the current at resistor 3, here's where we're at, is equal to the voltage at resistance 3 divided by the resistance of 3. The voltage is 15 volts. The resistance is 3.3 k ohms. 15 divided by 3.3 gives me 4.5 milliamp. All right, now we're going to calculate the total current. We can use, like we could the voltage law, we can use now a current law in a parallel circuit. And so all that tells us is the total current is equal to the current at resistor 1 plus the current at resistor 2 plus the current at resistor 3. And so when I do that, and so all we have to do is add up all of those current measurements. And so the current at resistor 1 we calculated, it was 31.9 milliamp, plus the current at resistor 2, 6.8 milliamp, the current at resistor 3, 4.5 milliamp. We add those up, 31.9 plus 6.8 plus 4.5, and we get, we'll just call it around 43 milliamp for our total current. Alright, so those are the keys to a parallel circuit. Remember that a parallel circuit, the voltage is constant. It's the same measurement. It's 15 volts no matter where it is. I'm taking the reading on the circuit. The current is variable. It changes, which is the opposite from a series circuit where the voltage is variable and the current is constant.